Let's solve some questions about motion graphs. Question number 1. Questions 1 or 2 are related to the same graph. So, an object moves in a straight line. The graph shows the relationship between the velocity and it shows the relationship between time. So it's a velocity versus time graph. Now, one of the most important things you must do as soon as you see a graph is you must identify the type of graph, which in our case it's a velocity versus time graph. Okay, so this is very important because it gives a total different meaning. Okay, so it's a velocity versus time graph. Okay, before I start dealing with the velocity versus time graph, I can do the following. I can write that the slope will give me the acceleration, and I can say that the area will give me the displacement. Okay, so keeping that in mind, let's see what the question is asking for. It's saying that the acceleration of the object, or it's asking me to find the acceleration of the object between 2 seconds and 5 seconds. Okay, so here's the 2-second point and here's this 5-second point. It's asking me to find the acceleration, but how can I find the acceleration? It's a velocity versus time graph, so I know that this slope will give me the acceleration. Okay, so I need to find the slope of this line. Let's take these 2 points and find the coordinates of these 2 points. The x coordinate is 2 and the y coordinate is 6, and here the x coordinate is equal to 5 and the y coordinate is equal to 9. Okay, so if I want to find the slope, I know that the slope is equal to, or the acceleration in this case, it's going to be the change in y over the change in x, which is equal to y2 minus y1 divided by x2 minus x1. Okay, now let's remember that this is x1, this is y1, and this is x2, and this is y2. Okay, so just plug in the numbers. Y2, it's equal to 9 minus 6 divided by 5 minus 2, which is equal to 3 over 3, which is equal to 1 meters per second square. So the acceleration is equal to 1 meters per second square. So the answer in this case is B. Now it's asking to find the distance the object travels during the first 2 seconds. So it's asking me to find the distance traveled in this area right here, in this zone right here. Okay, now it's important to remember, since I'm looking for the distance, I need the area. What's the area I'm looking for? I'm looking for the area below the graph. So I'm looking for this area right here, okay, this shaded area. How can I find this shaded area? Well, I can use a triangle and a rectangle, or I can use it as a trapezoid where this is the first base and this is the second base, etc. But I'm just going to use, for simplicity, a rectangle and a triangle. So let's call this area 1. And let's call this area 2. In our case, the displacement is going to be equal to area 1 plus area 2. Now, what's the first area? The first area, it's a rectangle. So it's base multiplied by height, which is from 0 to 2. So the base is equal to 2. Multiplied by the height from 0 to 2. So it's also 2. Now, plus the area of the second shape, which is a triangle, it's half multiplied by base multiplied by height. So it's half multiplied by the base, which is from 0 to 2. So it's 2. Multiplied by the height. Now the height's from 6 to 2. Some of you may just plug in the number 6. No, we need to be careful. The height is from here to here. So it's from 6 to 2. So it's only 4. And this gives us 4 plus 4, which is equal to 8 meters. Let's see our choices. So the choice is C. Next question. Question 3 and 4 refer to the next graph. A ball is launched up straight from the ground level on an initial speed equal to 30 meters per second. So I have the initial speed. Assume that the magnitude of the acceleration is 10 meters per second squared, and we know that's the gravitational acceleration. We introduced it before when we talked about motion in one dimension, but actually we introduced it as 9.8, but in this question it's asking me to use it as 10. Okay, remember that, or it says here that the effect of air resistance is negligible. The height x of the ball above the ground is plotted versus time. Okay, so what type of graph do we have here? We have a displacement versus time graph. Okay, now in a displacement versus time graph, we learned that we have a constant graph, we have a linear graph, we have a curved graph. As we can see, this is a curved graph. What can I find from a displacement versus time graph? I can say that the slope will give me the velocity. Okay, now let's see what the question is asking us to find. What are the speed and acceleration of the object at t equal 6 seconds. So it's asking me here, what's the speed of the object and the acceleration just before it hits the ground? Well, actually, let's look at the choices. The choices sometimes give me the answers. Okay, so it says here that just before it touches the ground, will its velocity be 0? No, that's impossible because it's still moving. Okay, so we can just jump choice A. We can also just neglect this choice, which is choice B. Now let's look at C and D. Now, it's saying here that the velocity will be 30, okay, which can also be correct. And it's saying that the acceleration is equal to 0. Okay, let's think about it for a second. And D says that the velocity will be 30 and the acceleration is going to be -10. So the difference here is the acceleration. Will the acceleration be 0? Well, that is impossible because the acceleration of the gravity is always equal to -10. Why the negative? Because it's a vector value and it's pointing downwards. The acceleration of the gravity, or in other words g, is always pointing downwards, so it has a value of -g, and the acceleration can never be 0. It is always constant. It is always -10. So the answer for 3, it's going to be D. Okay, let's see question 4. What are the speed and the acceleration at t equal to 3 seconds? So it's asking about the velocity right here and the acceleration. So we already mentioned that the acceleration can never be 0, so the correct answer is going to be either B or D. Now, which of them is the correct answer? Now, it's saying here that, it's asking me to find the speed. Now, how can I know the speed? Well, actually, it's common sense. At the highest point, when an object is thrown upwards, it said that the object is thrown upwards. At the highest point, it will stop and it will have a velocity Vy, final equal to 0. I think we already mentioned that in the previous chapter. But can I solve it in another way? Well, yes. Remember that we said that the slope is equal to the velocity. What's the slope here? Well, it's a curved graph. How can I find the slope? Well, by finding something we called, and we introduced previously, we called it the tangent. So if we draw a line just like this, which is just touching the graph, we will find a horizontal line, okay? And a horizontal line means that the slope is equal to 0. Now, whenever you see a horizontal line, you know that the slope is equal to 0 because y2 minus y1 is going to be equal to 0 because it has the same y value, okay? If we take this point here and this point here, it will have the same y value, so the slope will be equal to 0. So I can say, since the slope is equal to 0, this means that the velocity is equal to 0, so I can go with choice B. Okay? Next question. 2 cars A and B begin moving from start at time equal to 0 and race over the total distance equal to d. The graph as shown shows the respective distances from the starting line. So we are dealing with the distance versus time graph, okay? This distance versus time graph, we have 3 types of graphs. We have the linear, we have the constant, and we have the curved, and we can see that we are dealing with the third case because this is a curved graph. Now, which of these correct statements include the following? We have statement A, statement 1, statement 2, statement 3. Our choices say 1 only, 2 only, 1 and 3 only, 2 and 3 only. Okay, so let's read 1. 1 says that at time equal to t1, car A has a greater speed than car B. Okay, so it's asking about the speed. What is the speed in a distance versus time graph? We said that the slope in a distance versus time graph will give me the speed. So let's look at the slope at t equal 1 for time A. For graph A, the slope is going to be something like this, okay? It's going to be something like this, okay? So let's look at the slope of line B and the slope of line A. The slope of car A right here is way higher than the slope of car B. So we can say, since the slope of car A is larger than the slope of car B, we can say that the velocity of A is faster than the velocity of B. So 1 for sure is true. Now let's look at 2. At time equal t1, car A is closer to the finish line than car B. Well, some of you may say, yes, since car A is faster than car B, it may reach the finish line faster. Well, no, don't be too hasty, because if we look at this graph, it's a distance versus time graph. So I can see the distance of graph A or car A and the distance of car B at the same time. They will have the same distance. Let's call it, for example, D. So 2 will not be correct because again, at this point right here, they will have the same distance, okay? They will have the same distance. Now, so 2 is wrong. Let's see 3. Car A crosses the finish line first. Well, actually, it's common sense. Since car A has a higher speed than car B, and we can say that car A is accelerating because the graph is going upwards, the speed is increasing, while car B is decelerating. So since car A is becoming faster with time and car B is coming slower with time, for sure car A will cross the finish line first. So the true answer will be C. It's 1 and 3. In this question, it's saying that the graph above shows the rate at which water is pumped into a tank, measured in cubic meters per hour, as a function of time. The shaded area under the graph is equal to the average volume, the average rate of pumping, the average time, and finally the total volume. Okay, we never covered something called the rate versus time graph, but it's actually very similar to the velocity versus time graph. Why? Because it's showing, because the velocity is meters per second, and this is meters cubed per hour, so it's distance and time, okay? So we can just look at it as if it were a velocity versus time graph. Okay, so we know that in a velocity versus time graph, the shaded area will give me the distance. Well, actually, it's clear that the rate versus time graph, the total shaded area will give me the volume or the total volume of the shape, okay? So the answer in this case, it's going to be D. We can just look at it if it were a velocity versus time graph. Last question. Now, the 4 labeled curves below show speeds as a fraction of time for 4 cars. So we have a speed versus time graph. In other words, we have a velocity versus time graph. Again, in a velocity versus time graph, the slope will give me the acceleration and the area will give me the displacement. Now, keeping that in mind, let's see what the question is saying. It has 4 labels. Which car is moving the slowest at time equal t1? Okay, so it's asking about the velocity right here. Which has the lowest velocity right here? Well, as you can see, it's simply a speed versus time graph. So for object A, no, it's the fastest. B is slower. C is even slower. And the slowest one here in this case is going to be D. So the answer here is D. Okay? For the next question, which car travels the greatest distance from t equals 0 to t equal 2? Now, since asking about the distance, means it's asking about the area. Which of them has the greatest shaded area? Well, it's clear that it's B because here the shaded area of B, it's going to be this whole zone right here. So the answer is B. Now this is the end of this chapter. I hope to see you in the next chapters. We will be introducing projectiles. Stay tuned.